Hello, good morning, one and all. I, Professor Ram Khandare from Dr. D.Y. Patil College of Engineering and Innovation. As per we know all, this first year engineering, electrical engineering subjects exam is upcoming. So, for the revision purpose, I have made this video. So, we will be cover that 5 units in that video. So it's like a revision. The first we start with the elementary concept of and a DC circuit of that first unit, and that there is some important concept which we will be the cover now. So first is the resistance. So what is the resistance? We all the familiar with that, the opposition of flow of current. Whatever there is a opposition is there, we call as a resistance. So the formula of resistance is R is equal to rho L divided by area. The rho, all we know that the resistivity of that, whatever that resistance is made by that material, it's the resistivity of that. Second thing is a length of that wire, whatever it's made by that, what will be the length of it's depend on that factor, and the cross sectional area, that the rho L and area, that factor is going to affect it to that resistance. Second is the EMF. It's nothing but the electromotive force. The force is required to produce the fluxes. It's called as the electromotive force. So the EMF. Second one is the current. Current is nothing but the flowing of a charge per unit time, we call as a current. Third one is electric potential. It's nothing but the force work done required per unit charge, we call as the electric potential. The potential difference between the two charges, it's called as the potential difference, we also call as the voltage. The Ohm's law, when the current flowing through the conductor is directly proportional to the potential difference across its end, and inversely proportional to the resistance. So we all know the I is equal to V divided by R. I is directly proportional to the voltage and inversely proportional to the R. But R is nothing but the rho L divided by area, as the directly and indirectly the resistance, that factor affecting with that resistance is also we have to consider when we are considering the current. So most important thing is the classification of network. What actually the classification, what are the different types of the network? It would be the classified on the basis of that parameter of that network, basis of that separability of component, and on basis of the direction of that current, on the basis of the source. First we will see the linear. The linear and non-linear network is the depending upon the parameter. That linear, it's mean the parameter is depending upon the parameter of the current, voltage and temperature. Non-linear is do not be depending upon that the parameter. So lump and distributed, also lump, it's nothing but the it cannot be separate, it can be separated, and distributed, it cannot be separated. Unilateral means that the current can flow only one direction. Bilateral, current can go both direction. Active, there is at least only one sources or more than sources must be the present in that network, we call as a active network. And passive network, it means that there is a no source. The second thing is the series and parallel. We all know, and the current flowing through that both resistor is the same, as per we see that the current flowing that both resistor is the same, we call as a parallel series. And the current going to divide it, here some and here some, that resistance and that resistance, that same current, that total current I going to divide it here I1 and I2. So we can say that there is a two resistors are in the parallel. So Next concept is the star and delta. We are all know the parallel with the we all with the familiar with the star and delta already we have covered in our lecture. But it's what we can the delta when the three branches to form a closed loop we call as a delta, and three branches meet at a point we call as a star. So star to delta as per the star to delta conversion, we considering the one we are considering the one delta wala, there is second inside of there is a star, and we have to remove one branch. We have to remove one branch means that its circuit is looking like that. There is a R12, R23 and R31. Here is a R1 and there is a R2. So R1 plus R2 is equal to, we have the product of R12 into bracket, we can write like that, R1 plus R2 is equal to, take the product of that R12 into bracket, whatever x there is a 1 2 2 3 and 3 1, which two are remaining, R 2 3 plus R 3 1 are both are remaining, divided by R 1 2 plus R 2 3 plus R 3 1. Second R 2 plus R 3, that third one R1 branches we have removing, then we will get that 2 are in the series. The same take the product R23 into bracket, which one is remaining, R1 2 1 2 plus R23 divided by R12 plus R23 plus R31. R same for the R31. R31 is a R12, R23 and R31. Same, R3 plus R1 is equal to what? R31 into bracket R12 plus R21 divided by R12 plus R21 plus R31. Same, what we have to do, R12 minus R2 plus R3, we will get that 2 gone cancel, minus we will get the R1 minus R3. Same we have to do that R1 minus R3 plus R3 plus R1, that we will get the R1 minus R1 R1 minus R2. So we will get at the end that the equation at the right side. After the calculation, we will get the R1 is equal to R1A, R1 is equal to RA, it's nothing but the R1 is equal to, we will get the R12 divided by R1 plus R2 plus R3. Same, what will be the, we can draw the diagram. R12 plus R23 plus R31. Inside we will get the R1, here we will get the R2, here we will get the R3. So R1 is equal to adjacent, R1 is equal to adjacent R12 into R31 divided by R12 plus R23 plus R31. Same for the R2, what will be the adjacent? Which one is the R2 is the adjacent? So R1 it's R2. The adjacent is R12 and R23. R12 plus into R23 divided by R1 plus R2 plus R12 plus R23 plus R31. This is all is nothing but the star into delta, delta into star. And same here we have to take the product divided by in front of the value, and it's all about the delta. Already we have covered in our lectures, then it's just like a revision, so I will shortly that explain the derivation. Second, the elementary power of system. We all know the power we have get from the generation to the transmission, from distribution to our home appliances. How it will be the come? There is nothing but the one type of a diagram. There is generation is the energy, whatever that energy going to generate it. It's like a one example of Jayakwadi Prakalpa is there. A second one is a windmill is there. It will nothing but the generate the power, and that power is come from the transmission line through distribution to our houses. It's nothing but it's a one simple diagram we can understand by using that. There is a generation power station, from there is a power going to generated. There is a power transformer, you know that the transformer we can be used for the step up and step down purpose, is used to transfer the AC to AC signal or AC to AC supply. Then it's come to the transmission line. Through the transmission line, transmission substation is also there. Distribution, we have to distribute that supply uh, towards our home appliances, and at the end we will get the commercial industrial business and as well as the home appliances, that the power come from that. And for the commercial high power we are using the high power wala transformer, and for the simple home appliances we are using the three phase transformer. It may be the single phase transformer. We are all the familiar with the what is the transformer. It's nothing but the one type of a device, it's used to transfer the AC to AC signal. Its work on the mutual induction. When we supply fed to the primary coil, same current going to transfer or power transfer to the secondary coil. We already know the mutual induction concept and self induction. There is only one coil we are using. It's generated the uh, magnetic fluxes by its own, we call the self, and the flux is transferred to the primary winding to the secondary winding, or current transfer to the primary to the same current transfer to the secondary, we call as a mutual induction. So Kirchhoff's first law and Kirchhoff's second law, all we know that incoming current is equal to outgoing current, or sum of that incoming current is and outgoing current is equal to 0. And second, the Kirchhoff's voltage law, algebraic sum of that voltage drop across that element is equal to 0. Already we know that the KVL state are algebraic sum of the voltage drop, and in the closed loop it's nothing but the 0. It's we have already learned that same concept in the 8th standard, 5th standard, 6th standard. Already is very easy concept. The superposition theorem in the linear means its parameter must be same, must do not be changed when we are applying the current, voltage and temperature. Bilateral network means the current can be flow both directions. Such in any linear bilateral network, the voltage across or current through any given element is equal to the algebraic sum of individual voltage or the current produced independently across, or the element of each source acting independently when the remaining source replaced by their respectively internal resistance. There is a two condition is there when we are using the uh, current source. There is, suppose that there is a more than of two sources is there. If we can see here, there is a two type of a sources there, voltage source and current source. When we are what actually the superposition state, that it's like a one type of a coupling of that it is a one type of a pipe supposed to be, some water come here, some water current here come here, and total water we will get the total water here. Here is a type of coupling, a type of, it's a and it's a B type. But at the end we will get the total water, some water coming here, some water coming here. So we have to, same concept we have to use in the superposition theorem. What actually superposition theorem state that, superposition theorem state that ki at the end we will get the total current, am I correct? But how individually current is affected in that circuit, we have to find that first by using that voltage, how many current they can apply to that inside entire circuit. By using that second source is current source, how many current we will get to our to, and at the end we will get the total current, a dash from that voltage, B from that, and total I will get the IT is equal to IA plus IB. But the condition is, we are, when we are solving that problem, already we have learned and we have solved the problem. When the voltage source is there, we have to short, and current source we have to open. When we are considering the voltage source, we have to current source we have to open it. When we are considering the current source, we have to voltage source we have to short it. At the solve there, by and there we have to use the current divider formula or voltage divider formula. Same thing is there. Second unit is the electromagnetism. Electromagnetism is that the one concept, when the current passing through the any conductor, the magnetic flux is going produces along it. We can say that the electromagnet. So second thing is the magnetic field. The Maxwell right hand rule thumbs that, according to the right hand thumb rule, shows the, while the, where any conductor hold in right hand, that the entire forefinger shows the magnetic field and the thumb indicate the direction of current. So right hand thumb rule and right hand rule state that when three fingers stretch such a way that the thumb indicate the force, right, index finger indicate the current, and last middle finger indicate the flux. So it's also we have present in our syllabus. The some terminologies we have to cover. So what the permeability of free space, the ability to pass the fluxes, we can say that the permeability or the permission is given to pass to fluxes, we call as the permeability, is denoted by the mu, or in the free space the value of mu naught is a 4 pi into 10 raised to power minus 7. Second, absolute permeability, it's nothing but the ratio of flux density divided by the field strength. We can say that mu is equal to B divided by H. B is nothing but the flux per unit area. So our relative permeability is nothing but the ratio of permeability to the permeability through the air. We can, it's nothing but the definition of the terminology. Second thing is the magnetomotive force. The magnetomotive force is nothing but the force required to flow the fluxes. mmf it's nothing but the second definition we can be considered, it's a product of number of turns to the current. mmf is equal to n into I. So what will be the unit of n into I? N is nothing but the turns, means T, and current is nothing but the A. So AT is nothing but the unit of that magnetomotive force. What will be the flux? Flux is nothing but the imaginary lines which is present in the magnetic field. The phi is equal to mmf divided by S. So phi is equal to, its unit is nothing but the Weber. So mmf unit is the AT, and S is nothing but the opposition flow of flux. The what will be the unit of S is equal to AT per Weber. So what is the flux density? Flux is nothing but the flux per unit area. So what will be the flux unit is Weber, and area is nothing but the meter. So Weber per meter. Reluctance is nothing but the opposition of law of fluxes. Yes, we have covered that, and its units already we have find the AT divided by Weber. Permeance is nothing but the ability to pass the fluxes. The unit is a Weber per AT. Magnetic field strength of intensity, it's a ratio of mmf to the length. So mmf is equal to, the unit is AT and length is meter, AT per meter. So it's all about the intensity. So second thing is the magnetic circuit. There are the two types of a magnetic circuit: simple series and series parallel. So in our syllabus just we having the series and that the parallel. The electric circuit magnetic, what will be the comparison between the electric and magnetic circuit? Before that we will cover that what is the series magnetic circuit and parallel magnetic circuit. In case of series magnetic circuit, it's supposed to be there are the two magnet which connected. It's one magnet, A1 magnet. We will draw perfectly diagram. It's second, it's supposed to be, it's we have fed ES1 and it will be the ES2. There are the two magnet, there will be the phi 1, there will be the phi 2, there will be mmf 1 and there will be the mmf 2. It's nothing but the two magnet which connected in the series. So we know the magnet is connected into the series. What will be the same? There is a flux going to same when the two resistors are in the connected in the series, current same. When the two magnet are in the connected in the series, will be the magnet going to same. So what is the different is nothing but the EMMF. So phi is equal to EMMF divided by ES. We have to consider comparison between phi and EMMF. So what is the different? EMMF is different. EMMF T is equal to, what will be the EMMF T is equal to EMMF 1 plus EMMF 2. So what will be the EMMF? Phi divided by, yes, the T, or it's a T, it is a phi divided by S1 plus phi divided by S2. Why it is so? Sorry, EMMF is phi is equal to EMMF divided by S. So phi is EMMF is equal to phi t into ST is equal to phi 1 into S1 plus phi 2 into S2. What is the same? Phi is the same. So take outside phi, S1 plus S2. So phi gone cancel. We will get the ST is equal to S1 plus S2. It's all are in the series. What will be the in the parallel? It's supposed to be, it's a parallel. So what will be the in case of series, flux is same, EMF is different. In case of parallel, what will be the same? In case of the parallel, EMF is same, the phi going to different. Phi t is equal to phi 1 plus phi 2. So phi is nothing but the mmf divided by st. mmf divided by s1 plus mmf divided by s2. What will be the same? mmf going to same. So take the outside mmf, 1 upon s1 plus 1 upon s2. There is a mmf divided by st. The mmf gone cancel. We will get st is equal to 1 upon s1 plus 1 upon s2. It's all about that. When the two magnet in the series, we will get the st is equal to s1 plus s2. When the two magnet are in the parallel, we will get the 1 upon s1 plus 1 upon s2. What will be the comparison between electric and magnetic? Always electric circuit traced to the current and magnetic always traced to the flux. EMF is driven to the force. Here is the mmf is there. There is a phi. Phi is equal to mmf divided by s. As per the Ohm's law, there is a I is equal to V divided by R. There is a current, there is a flux, there is a voltage, there is a magnetic force, there is a electromotive force, there is a resistance, there is a reluctance. Electric lines is not closed. The magnetic field lines are always closed. Electric lines start from the positive terminal to negative. Magnetic lines flow from the north pole to south pole. It's all about that, the comparison between that. Second thing is the electromagnetic induction, the Faraday's first law. When any conductor placed in the magnetic field, then induced EMF generated inside of that the conductor, we all know, Or Faraday's second law, what actually the Faraday's second law state that E is equal to minus n d phi upon dt, means induced EMF is directly proportional to the product of number of a turn and the rate of change of flux with respect to time. It's nothing but that Fleming right hand thumb rule chess already we have discussed that at the start. When three fingers stretch such a way that they perpendicular to the each other, thumb shows the motion, index finger shows the field, and index shows the current air, or there is a last finger shows the magnetic field. There is something correction is there. Types of dynamic induced EMF, static induced EMF. Dynamic means then always the conductor going rotating in condition. Static is always there in the uh, stable or stable in condition. The self and mutual, there is a example of that already. We know that in case of self, there is a only one, we have had to supply that only one magnetic coil is there. When the supply is fed to that, flux is going to generated by its own. When in case of mutual, there is a primary and there is a secondary winding. We are connecting the one resistor here, we are connecting the supply here. The when we supply fed to that, magnetic flux is transferred to the same fluxes is transferred to the secondary winding. There is a mutually there is not connected to that coil, they are mutually connected. So that same self induction and mutual induction, what will be the derivation for that? In case of self induction, phi is equal to phi 1 to I into phi is equal to phi divided by I into I. As per that, we have to differentiate d phi upon dt. D phi upon dt is equal to I into I di upon dt. As per the Faraday's second law, E is equal to n d phi upon dt is already we having the phi, so E is equal to minus n phi I divided by I into d phi upon dt. So at the end, what we have get, E is equal to n phi divided by I into di upon dt, or n phi divided by I is nothing but the denoted by L is nothing but the self coefficient. So self coefficient or second self inductance, and second one is denoted by the L, and mutual induction phi 1 is equal to phi 2 I1 into I2. Same we have to with respect to I d phi divided by dt, there is a phi 2 into I1, so d I2 divided by dt. So at the end we will get the E is equal to n phi 1 divided by I2. So it is nothing but denoted by the it's mutual, it's denoted by n, it's nothing but mutual coefficient. Second one is the energy stored in the magnetic field. It's a very simple derivation for that also. E is equal to, we have to write P into dt. P is equal to I into V into dt. So I is equal to V is equal to self coefficient is there. Only one coil, energy stored in magnetic field means only one coil is there. So self coefficient wala formula L is equal to di upon dt. dt gone cancel, we will get the I is equal to L into di integration that, which one is a variable, I is a variable, so I indicates I square divided by 2, so E is equal to I squared divided by 2 into L, so Li square divided by 2. Just it's nothing but the derivation for that. Second is the AC fundamental. What will be the AC fundamental? As per the any Faraday's first law state that the any conductor placed in the magnetic field, what will be the happen? The induced EMF going to generated inside of that. So if suppose is the magnet, we have placed one, there is a n pole, 9 pole, and there is a n pole and p pole, the magnetic flux is going to generated. Magnetic pole going to generated like that. If suppose we have placed one conductor as a horizontal, there is not cut the fluxes, so there is a 0. When we have placed perpendicular, that it will be the cut the fluxes. It will again be horizontal, again we have kept its location is vertical, again it's a horizontal, we will get the sine wave. So it's nothing but the generation of AC fundamental. Now terminologies of some waveform. Some it's a set of positive and negative portion of alternative quantity we call as a waveform. Instantaneous value, it's defined as the instant value of that waveform, we call as instantaneous value. Cycle is a set of positive and set of negative portion of that alternative quantity, we call as the waveform. Time required to complete one cycle, how we can call as the one cycle? It is nothing but the one positive and one negative, we call as a set of positive portion, set of negative waveform. Period, time required to complete one cycle, it is nothing but the one cycle. Complete the one cycle we call as a period. Frequency, rate of change of time required to complete cycle in 1 second, we call as a frequency. Angular frequency, and the omega is equal to 2 pi f. RMS value already, that I is equal to 0.707, average value 0.6, form factor it's a ratio of RMS value to the, it's the ratio of RMS value to the average value, and the peak factor it's max value to the RMS value. It's all about the some definition. Some phase representation equation is there. Second is a type phase difference. The phase difference between two alternative quantity is 0. The phase difference between the two alternative quantity is a 0, we call as a in phase. The phase difference between two alternative quantity is a positive, we call as a leading. And the phase difference between two alternative, phase when the phase difference between two alternative quantity is a positive, because the leading. The phase difference between two alternative quantity is negative, we call as a lagging. The pure resistance, the is a very simple some derivation of that. As per the Ohm's law, I is equal to V divided by R. So we having the Vm, we having the here V is equal to Vm sine of omega t divided by R. So we will get the I is equal to, that both is a Im sine of omega t. So input is a Vm. So input is a Vm sine of omega t, and output is a I of t is equal to Im sine of omega t, plus 0 plus 0. The phase difference is a 0, because of that we will get the phasor diagram, and waveform is like that, same start same end, because phase difference is a 0. It's a power, we know that I is equal to I of is equal to, what will be the Vm sine, P is equal to I into V. So we have I is equal to Im sine omega t, or Vm is equal to sine omega t. So Im into Vm sine square omega t. The sine square is nothing but the Vm 1 minus cos 2 omega t divided by 2. So Im Vm divided by 2 minus cos 2 omega t is always 0. So we will get the Im Vm divided by 2. The second is a pure capacity. It's also pure capacity is very simple derivation of that inductive and simple capacitive. Always phase difference is a positive, because it's the leading, and inductive always phase difference is a negative, because it's the lagging. For the capacitor, I is equal to dq upon dt. The d upon dt is equal to cv. So d upon dt c into Vm sin omega t. So what will be the C is equal to t upon dt Vm sin of omega t. So what will be the derivative of that? The derivative of that, Vm is equal to d upon dt Vm sin of omega t. So Vm already we have taken. The Vm is equal to cos of omega t into omega. Cos of omega t into omega. So at the end we will get, so I is equal to dq upon dt. At the end omega we will get the C, omega c is equal to Vm into sin of omega t. Vm divided by omega c is nothing but the Vm divided by xc is equal to sin of omega t. It is nothing but the I of Vm sin of omega t. It's all about the derivation. Same derivation we have in the pure inductor also. So it start with the pure capacitors. I is equal to dq upon dt. Or same we have to start with the for the inductive V is equal to L di upon dt. Always we are finding the current, so di upon dt is equal to V divided by L. So V is nothing but the Vm sin omega t. Just put in the value and find out that same Vm sin omega t. So V dm divided by L, we will get the integration of that omega L, and that sin omega t is nothing but the cos of omega t, or it's nothing but the xcl is equal to cos of omega t minus pi by 2. There is a plus pi by 2. It's all about the AC fundamental. Already we have learned the series, parallel, phasor diagram. What the phasor, we have know the power triangle, power factor already we learn. Apparent power, it's nothing but the it's denoted by S. Active power P, and the imaginary power, reactive power, is denoted by Q. Already we have learned the RL. Yes, we have in the practical, in the lecture also I have told that it's we have to consider here XL, we have to consider XC. So it is nothing but or it is nothing but Z, or it is nothing but Z. For inductance, for the inductor, just we have to draw that triangle. It is a XL, R and Z. For the capacitor, we have draw that triangle XC, R and Z. By Pythagoras प्रमेय we can find the everything, voltage, current, capacitor, everything. Just we can already we have learned that waveform, RL circuit, RC circuit. That same we have to apply that. We can find that, for example, Z is equal to under root of, you can see here, if supposed to be Z square is equal to R square minus X square, so Z is equal to under root of R square minus XC. It's a Pythagoras प्रमेय. It is very easy, already we have learned in the class. It is not very difficult. So resonance is equal to XL into XC. How we can find the resonance? Just we will see that XL is equal to XC. What will be the XL? 2 pi f C, 1 upon 2 pi f C. Here is a, wait, XL is equal to 2, XL is equal to XC. XL is a 2 pi f L, and XC is equal to 1 upon 2 pi f C. So we have to find the frequency. So f square is equal to what we will get, the 1 upon 2 pi square, 2 square into L into C. Take its square 1 upon 2 pi into under root of LC. It is all about the resonance frequency and all. The resonance 1 upon 2 pi fc. Power factor is always required 1 if you want to perfect output. Impedance Z is equal to R in case of resonant condition, and current is I is equal to V divided by R. The three-phase circuit, the notation of RYB, what is the line, what is the phase current, when the current passing through the phase, call the phase, current passing through the line, call the line, nomination, and that all we have learned. It is nothing but the diagram of waveform of that. Second is the phasor diagram. E is equal to EM sin. Always we can consider that the three phase, when always we require the three phase, apart from three phase each other is the 120 degree. Apart from that angle is a 120 degree. Always the impedance requires same. Apart from angle is a 120 degree. One is R, Y and B. If the phase sequence of RYB is we get the voltage is large, we call as a positive. When the phase such a sequence we will get the negative value, we call it the negative. And the such a sequence we will get the max value, we call the phase sequence. RYB is always the phase sequence. Three types of there are the two type of star and delta. When three, already we have discussed three phases to meet at a single three phases meet at one point, we call as a star, and three phases form a closed loop, we call as a delta connection. Already here we can see a star or delta. How is there is the one derivation is there. VL is equal to root 3 VL is equal to root 3 VPH. We have to use same derivation for both IL and VL. Just we have to draw one phasor diagram. That one line is such type of a diagram. One line is passed through out of any that supposed to be this line. There is one line when we are perpendicular that it divided into 2A into B is supposed to be D. It is a VPH, or it is a VPH, it is a VL line. So we know that OA is equal to AB. So OB is equal to 2, or VL divided by 2, or VL is equal to same is equal to 2. Is this correct? Okay. So it is a 30. The cos 30 is always is equal to root 3 divided by 2. Correct? The cos 30 root 3 divided by 2. So we have is equal to root 3 divided by 2 is equal to then VL divided by 2. What is the cos 30? Says that cos means that adjacent divided by hypotenuse. That just we have diagram we have draw. The one adjacent divided by hypotenuse, it's nothing but the adjacent, and it's nothing but the hypotenuse. So adjacent divided, so it's a hypotenuse or it's a adjacent divided by hypotenuse. So VL divided by 2 divided by VPH. So it is nothing but the root 3 divided by 2. So VL divided by 2 VPH is equal to root 3 divided by 2. 2 can cancel. We will get that as VL is equal to root 3 VPH. At the last we will get the VL is equal to root 3 VPH. Same we have to consider for the current as well. So its last introduction to the electric machine. What is a transformer? Is device which use the electric power transfer one circuit to the another circuit. This already we have learned. Efficiency 90%. Its work on the mutual induction, Faraday electromagnetic induction, that already we have learned. There is having the two coil, and the current passing to the primary coil, current is transferred to the secondary coil. What actually contain is the construction of transformer. There is a magnetic core. There is a one magnetic core, rectangular square shape. It consists of a vertical portion is called as a limb, and horizontal it's called as a yoke. Already there is shown yoke is the form of one coil and to the another. Carrier flux, yoke is carrier flux lamination, or it's required lamp to remove to save from the eddy current. Thickness is lambda 0.3, and that working of that core. Seeing transformer, there is one transformer large tank, steel tank is there. We are dipping that oil inside of that, and any type of that transformer type. There is also the breather for the temperature inside the transformer increases the oil. It's in the extended the temperature going to then the oil contract. The breathers is used for the removing the gases. The backlash relay is the gas operated to release, which is a brake to contact to protect the transformer if there is any fault in the transformer. Explosive vent is contain no metallic diaphragm when it's shown as the diagram. It's yet application of transformer, something already we have learned in that. What is the step up and step up in increasing the output voltage, decreasing the output voltage? Already we learned that when the winding n1 is greater than n2, then it's a n1 is greater than step up. N1 means primary winding is greater than the secondary winding, that we call that step down, and secondary winding is greater, we call as the step up. Already we can see here increasing output voltage, decreasing output voltage. Current is law of secondary, you can learn that, you can read that. Already we have some shell type and berry type. Shell type core is there is the two, the shell type and core type. Already here is the diagram is shell type and core type. There is one rectangular, both side there is a starting and ending, the ending there is a limbs. There is a having the winding, and there is a middle of only the shell type is there is a middle of that limb. There is a primary and secondary coin going to wound. It is a core type. There is, you can see the only one window. There is, you can see the two windows, and all that comparisons already is given, you can read there. And berry type, it look like a cycle spokes type. It consists of two winding. Always we have to write it consists of two, just I have teach in the class. There is the two winding, and as per the mutual induction, when the primary power fed to the primary coil, same current going to transfer to the secondary wind. As per that, it's nothing but the working, it's work on the mutual induction. Same the Faraday's first law electromagnetic concept says that when the field supply to the any coil or the magnetic flux going to generate itself. And the first concept is electromagnet, second is the uh, Faraday's first Faraday or mutual induction concept. There is just two concepts we are using in that transformer. The electro EMF equation as per the Faraday's law is equal to minus n d phi upon dt. The minus n phi m is equal to 2 pi of t divided by dt. We get the derivative n phi cos 2 pi of t, and always 2 pi of t is the 1. At the end we get the E is equal to 4.44 phi of n. It's very easy as some ratio of definition. Turns ratio is the ratio of primary turns to the secondary EMF ratio. It's a primary EMF to the secondary EMF, and that transformer coefficient only we have to change the value of current, that E2 upon E1, N2 upon N1, V2 upon N1, there is equal to I1 upon I2. The equation of KVA into this already we have learned. Some hysteresis losses means that the magnetization and demagnetization is not done properly, then going to hysteresis loss. Eddy current losses means that current passing throughout of that core, not to the coil. Then some current going to the losses in that core, so we call as a eddy current losses. Copper losses due to the copper wire, ohms losses or copper loss due to this resistance, and that all about the efficiency definition formulas we can read here. Like the DC motor, there is a stator, there is a yoke, there is a pole. Stator used for the primary winding and stator, rotor used for the secondary winding. In case of that DC motor, there is not a rotor, there is a commutator. So we have is the, as per the diagram, as per shown the diagram, when we there is a stator winding, we fed the supply to the stator winding. As per the electromagnetic and magnetic flux going to generated, there is a winding is wound to the uh, pole is used for the winding purpose, pole is used for the collect the fluxes. Then fluxes going to increases when we are increasing the power, then it will be stuck to the commutator, and that commutator is nothing but the, as per the Faraday's first law, when the current, when any conductor placed in the magnetic field, that collect and induce EMF going to generate inside of same concept, that the commutator collect the current and then induce EMF going to generate it, and then